The power triangle concept, it simplifies the understanding of calculating the power. So if you have the power triangle here, you have the power, it's the horizontal one, the real or the active power P, and the perpendicular component is the reactive power, and it's positive when it's lagging, it's negative downward when it's leading. And the apparent power or the complex power S has a magnitude and it has a direction with angle theta. There are relationships between P, Q, S, as you know, as Pythagorean. So P squared plus Q squared, you can get the apparent power. And there's a relationship between the power factor, power, and complex power. So power factor, which is cosine theta, it's the same, the ratio between the power and S. That's very important relationship that we'll need it. When you have two loads in parallel, how you deal with it? The best thing to do, and that's actually the practical life, because when you connect loads anywhere in industry, in homes, and everything like that, you put everything the plug to the outlet, so the same voltage apply to the all loads. So all loads are connected in real life. Why? To have the same voltage, because most the appliances, devices, equipment operate on 110 voltage. So you have the same voltage. So when they are in parallel, I gave you here one example that if you have two loads, one Z1, the other one Z2. So how we calculate the complex power using voltage, current, impedance. If you know the voltage, you will say the complex power S is equal V times I conjugate. If you don't have, if you have something else, you have Z. So how we calculate so you can say that the complex power is equal V and square, but you're not going to have this, it has to be the magnitude of the voltage. Don't look at the angle, and square and divided by the conjugate of the impedance. That's the way you calculate the complex power. V square over Z conjugate. It's very similar. If you remember the power that you learned before with DC, we say that the power is equal I square R, V square over R, or V times I, right? It's the same, but now we're replacing R with Z. So it, and of course, don't forget the conjugate. So the complex power S is equal the voltage times the conjugate of current, or the voltage square over Z. What voltage is important again? What voltage? Any voltage? No. If you want to find the complex power on impedance Z1, so we'll have V, the voltage across the impedance Z1, the magnitude only, square. Then divided by the conjugate of Z1. If you want to find the complex power across the second load, Z2, what you'll do, find the voltage magnitude across Z2 squared divided by the conjugate of the impedance Z2. Then you will get S1 and S2. And S1 and S2 will be phasor or vectors. Then you can add the vectors. Don't add the magnitude of apparent power. That's why I put your table that will help you when you have two parallel impedance or load. You have the load 1, 2 total, and then you have the power Q, S, power factors and the type. And for power, you see what the power is. If it's given, you can put it there. If it's not given, giving S, you put S, and then you continue to complete each column. How will do that? Let's do something practical. But it's a very helpful table. This one, let's just work together with it. Every two students will work on this problem, and we'll work it together. And every single minute, you can ask me how I can do that. That's two load impedances, Z1 and Z2, and they are given. H1 is given here. And we need first to calculate the total apparent power, that will be consumed by this load. So how we can do that? First, we have to calculate the complex power in Z1. How you calculate the complex power in Z1? It's given the impedance and the voltage. That's the voltage. And that's the impedance Z1, 16 angle negative 30. So let's work together. How can you calculate S1, complex power S1? Let's write here S1 complex. Anybody has an answer? Just explain it in the last slide. Yes. Just give me expression before numbers. How you calculate the complex power in impedance Z1? Voltage, only voltage or voltage square? Voltage square, okay. The voltage across Z1, I say V1 square, yes, divided by, not Z1, exactly. The conjugate of Z1, the conjugate of Z1. Z1 conjugate, all right. What is V1 magnitude? What is the voltage across Z1? 120, exactly. And that's will be square divided by Z1 conjugate. What is Z1? Angle negative 30. So what's the conjugate of Z1? Exactly, will be Z, sorry. An angle plus 30. And then you calculate that using a calculator that has complex. Right. So that's the way you're going to calculate the. I got it it'll be easy, 240, and the angle negative 30. You can make it's better to convert it to complex. So I got 207.85 minus J1. That's volt M. That's the way you calculate S1, the complex power by drawn by the first impedance. And the same thing, how we can find S2 will be the same thing. The voltage V2 magnitude square divided by the conjugate of the impedance Z2. What is the voltage across Z2? It's the same. They are in parallel. The same would be 120 volts, right? So we have 120 square divided by the impedance, the conjugate of impedance Z2. The impedance Z2 is equal 40 on angle 45. So it will be 40. And the angle, the sign will be flipped to be negative.
So because of the absolute, we ignore that.
You ignore the angle, exactly, because of the absolute. And that's a good question. For example, if you have 120 on angle, yes, it's angle 10. Yeah, I don't take the angle, take only the magnitude. And you do that, you can find the complex power in Z2, which will be equal to 54. Six plus J2 4.6 volt amp. Once you get S1 and S2, everything is solved. You want to find the total apparent power. Then you say S total complex power equal to S1 plus S2. You add both results. I added both, I got 462 plus J 134.6 volt amp. That was the first question to find the ask about the total apparent power. Now we got to do that's the complex part. The apparent power, it will be only the magnitude. So try to find the magnitude of this quantity plus J 134.6. I got it 481.6 volt. Of course, how you can find you will just make square root, the first one square and the second one square. That's what you do. Find the total. So that's the apparent power. So if the question was find the apparent power, that would be the answer, 481.6 volt amp. Any question this part? Yes.
So the apparent power is just the sum of the complex powers?
The magnitude of the sum of both complex powers. Yeah. First, you have to add them as a phasor. Then we got real and imaginary. Then you square the real and the imaginary, get the square root.
So I squared the j, it's going to be negative.
Which one? No. You square the magnitude only. Okay, let me make this clear. That's good question. Oops. That will be the square root of 462.4 square plus. Because when you look at it, that will be the total power, and that will be the total reactive power, and that will be the total apparent power. So you only define the square value of the magnitude. J means 90 degrees. All right. Any question for this one? Find the real power. So how you find the real power? The total real power. It's easy. The real part of the complex power. That's right. Because when you look at the complex power, the total complex power, that will be that will represent the total active power, and that will represent the total reactive power. That's right. So you can say that the total active power is equal to 462.4. I think the unit was kilowatt or what? No, it's normal watt. And the imaginary part that will represent the total reactive power, QT, that's equal to 134.6 volt amp. And observe that the sign of QT, is it positive or negative? The sign of the Q, positive, right? What does it mean? Does it mean the total power factor of the system lagging or leading? Lagging, that's right. So I'll say since UT is positive, lagging. Power factor is lagging. I'm sure you ask about the power factor. How can you find the power factor of the whole system?
The unit for Q, I think.
That's right, they are. Thank you. Volt and they react. So how can you find the total power factor? Exactly. Divide the active power, the watts, over the total VA. So it's equal total power over apparent power. Total power is equal 462.4 divided by S total, we just got it there. That's S total, 481.6 watt over VA. You get the ratio? It's 0.96, right? All right, 0.96. And it's not completely right, lagging. Yes. That will solve. So if you have two parallel loads, that's the way you do it. You can use this table, of course, to organize your answer. Well, I will leave it for you to solve it by yourself now, as a practice every two, and then you submit it to me. I'll give you 10 minutes. That's exactly like the exam. It's not a quiz. You can share with your friends every two, and you only submit for me only one paper has both names. This table will help you. The first thing you do, try to, let me help you in the first step. Let's put together the information and then you continue to calculate the rest. Two loads connect in parallel, like we did in the first example, are respectively 2 kilowatts. So that's the first load, 2 kilowatts. You put 2 here. And power factor 0.75. You put 0.75. And the type lagging, right? Or leading. Leading, sorry. So the second load is 4 kilowatt and the power factor is 0.95 and it's lagging. All right. The question calculates the power factor of the two loads. So I try to find all these values. It will help you to find. So how to find? You have to complete the table, the first two columns to the left. So work together and get it. Like you guys work together. Don't work individually, so we can share the ideas. Flip the chairs, move around, just do whatever you like. Be clean.
One of the exercises, and I have done
Yes.
it. But
Are you okay?
yeah, but I did it in a different way than.
You got 0.997 leading, right? I think you're right. I think you're right. That's your right. That's right. Okay.